Hi, everyone. Just wanted to take a moment to talk a little bit about completing the square when a is greater than 1. So basically, your steps are going to be the same. You're still going to end up dividing the middle term by 2, divided by 2, and everything like that. The only difference comes in really at the start. So the big difference that you have to be careful with is going to be that you have an a, right? Now you have an a. So the first thing you are always going to do is essentially you're going to divide everything by a. All right, so in this case, I'm going to divide everything by 4. All right, divide by 4, divide by 4, divide by 4. Now, you like situations like this where things cancel out nicely. All right, so what is 56 divided by 4? Well, that appears to be, drawing a blank, 14. 14x, and that is equal to negative 156 divided by 4 is going to be negative 39. Okay, now if that doesn't happen, you're going to end up with fractions, and that might make your life a little bit harder, but ultimately, you're going to go through that process anyway. Okay, you need a equal to 1 because otherwise things get a little complicated. Okay, so my recommendation to you is, if you are in a situation where you have a equals not 1 and it doesn't all divide out, maybe don't complete the square unless you really have to, okay? Just because you're going to be dealing with a lot of fractions. It will work, but it is a little bit cumbersome. All right, so now we're going to go through this process again. I need to find that over 2, which is 7. So I'm going to add 49 to both sides. So x squared plus 14x plus 49, oops, is equal to negative 39 plus 49, which is 10. Okay, so you get x plus 7 squared is equal to 10. So x plus 7 is equal to plus or minus root 10. So x equals negative 7, plus or minus root 10. Okay, so let's make sure I did that right. Negative 7 plus or minus square root of 10. There we go. Let's do another one for good measure, just to make sure we're all on the same page. We just did one with 4. Let's do one with a different number. They really like 4. 3. All right, let's do one with, that was too small of numbers. Let's do this one. All right, so on this one, you're going to, again, you need to start with the same process. However, before we do that, let's just get this in the correct form. So when you're completing the square, don't forget you want the x and the x squared term on one side, and you want the number on the other side by itself. So I'm just going to subtract the 6x from both sides. I'm going to get 3x squared minus 6x, and that is going to be equal to 72. All right, now I'm going to divide everything by 3. I'm going to get x squared minus 2x is equal to, what is that divided by 3? 24. Okay, now I need negative 2 over 1 is equal to, negative 1. Negative 1 squared is 1, so plus 1 plus 1. That's actually going to be a nice one, right? So that gives you x squared minus 2x plus 1 equals 25, which gives you x minus 1 squared is equal to 25. So x minus 1 is equal to root plus or minus root 25. So x minus 1 is equal to plus or minus 5. Now, basically, when you get something like this, what does this mean? This means it was factorable. It might not have been a readily apparently factorable, but it was actually factorable. So x equals 1 plus or minus 5. Well, what is 1 plus 5? Well, that's 6. What is 1 minus 5? That's negative 4, right? So actually, if we rewrote this, right, we divided everything by 3, we would have gotten 3x, we've got an x squared minus 2x minus 24 equals 0. So that actually would have been x minus 6, x plus 4. All right. So anyway, that is how you go through this process when a is not equal to 1. Divide out the a and then go through the process the same way you would have always. It gets annoying when a doesn't nicely cancel out because then you will end up with fractions. In particular, sometimes you end up with some annoying fractions, but The concept's the same. All right. Let me know if you have any questions, and have a great day.